Excuse me, sir.
Hello.
So this problem is too long. Any shortcut?
This one we can't go shortcuts because we need theta and we need the
And this one?
thetas. So what has made it too long is because we are unable to find the standard theta. If we found a standard theta, it would have been very easy because if theta was 45, when you say cos theta, it would then come out. Sin theta would come out easily.
Okay. So it's due to the fractions. Eh?
Yes.
And sir, why do we use the inverse of cos instead of cos itself?
Why do you use cos 2 theta? So we use cos theta because
Instead of using
What's your question?
I was saying, why do we use tan and not of course?
And not of course, because the one that is linked to the general equation, the one that is linked to this, then we say from this, tan 2 theta is b over a minus c. Then we also say cot 2 theta is a minus c over b from this general equation. So we don't have a direct cos or a direct sine. They are all in tan and in cot. So because of this, we only get to sine and cos once we get a value of theta. So when you find that this value of tan here is not standard, it's also a fraction a over b, what do? You then go to the triangle where you get a, b, if you put 2 theta here, and then you find c. And then from there, because you don't have the theta, so you'll be forced to get cos 2 theta. You'll be forced to get sine 2 theta. And then from there, after you get these, there also be fractions. So cos 2 theta will be b over c, and sine 2 theta will be a over c. So when you get these, you go to their double angle formulas where you say the square root of 1 over 2, 1 plus cos 2 theta. And then sine theta, the square root of 1 over 2, 1 minus cos 2 theta. So it's not even important to get this variant because you just get to use the same cos 2 theta, cos 2 theta. So at once I have my cos, I also have my sine. Then now you can go to the equation given, because we are given x prime as some number 7 over 2. Because we know the equation of the relationship between x prime and cos and sine. So you say, okay, because I know that x prime is x cos theta plus y sine theta, then I will have 7 over 2 here because it's given, and then x cos theta plus y sine theta. Then substitute these because you have now found them in either way here. So this question can be put in any way. So you should be quick once you notice that, oh, I can't get the actual numbers here. I can't get the proper angle. Then go to the triangle and see what you have as a sine theta, as a cos theta. So what's the next question? The next question is show that the polar equation for an ellipse centered at the origin with vertical focal axis can be written in the form r squared is equal, so this is 2a, r squared is equal to b squared over 1 minus e squared sine squared theta. So that you can write it like that. So what do you do? So you say, okay, if I have this, so the vertical focal axis, it means that the ellipse is going to be y squared over a squared plus x squared over b squared is equal to 1. Remember, centered at the origin, so the hk, that is 0,0, and then with a vertical focal axis, so it's elongated along the y-axis. This is how the original one should be. Then we also know that x is equal to r cos theta and y is equal to r sine theta. This much we know. Okay, so because we know that that is the case, when we come here, we'll say where there is y, we have r sine theta squared over a squared. Where there is x, we have r cos theta squared over b squared is equal to 1. So because it is 1, then you get a common denominator on the left. Those are fractions. So a squared, b squared, and then we'll have b squared, r squared, sine squared theta, plus a squared, r squared, cos squared theta is equal to 1. So from there, we cross multiply. So have this. In fact, as you cross multiply, you can factor out what is common there. The r squared. Remember, our target is to solve for r squared. So you factor out r squared, we remain with the b squared sine squared theta plus a squared cos squared theta. This is equal to a squared b squared as you cross multiply. Then you divide. We want to remain with r squared. So we take everything else the other side. So we have b squared sine squared theta plus a squared cos squared theta. Then you also check. The question gives you a clue. Check. Where should we go? We need b squared on top and sine squared in this. So we can rearrange. Now this becomes r squared is equal to a squared b squared over a squared cos squared theta plus b squared sine squared theta, like this. And then first thing, we factor out a squared. So have a squared b squared, and then down we factor out a squared. And then we remain with cos squared theta plus b squared over a squared sine squared theta in the down part. Then this and this will cancel. So remain with b squared on top, which is what we want, and down cos squared theta plus b squared a squared and sine squared theta, like this. And then what else? You say, okay, so for cos to go away, we can change it to sine. 1 minus sine squared theta. And then plus b squared, a squared, sine squared theta. So this would leave us with b squared, and then 1, and then get the a squared down. So have, we maintain the minus, so minus, remember there is 1 here. So 1 here, it will give us sine squared theta. And then with a squared, of course. And then plus b squared sine squared theta. So giving us b squared over 1 minus sine, so have a squared minus b squared over a squared, and then sine squared theta. But remember that for an ellipse, c squared is a squared minus b squared for an ellipse. And then we also know that E is c over a. So that if you square, even the right must be squared. So this is giving us a b squared on top over 1 minus, where we have a squared minus b squared, we just have c squared over a squared, and then the sine squared theta, which is equal to b squared over 1 minus e squared sine squared theta. Then you end there because you have shown that that is the case. So somebody there can choose to place a squared on top, and then they work out the down part so that it suits that. It will be now our job to remove, to treat it. So if they want to put a squared, they can just change the focal. They can say, okay, where the focal is the x-axis. The focal axis. Okay. Then we go to the other one. Discuss the conic section. B. Discuss the conic section. R is equal to 11 over half plus half sine theta. So as you discuss, you can just first line 11 over factor out half. Then you remain with 1 plus sine theta. Then push this guy up. So you have 11 over half over 1 plus sine theta. But that guy is just the same as 22 over 1 plus sine theta. Something like that. Then now you know it's a plus. So if it's a plus, what happens? And of course, we know that the ED, if you want E multiplied by the matrix, is equal to 22. And remember, E comes from the original one, should be ED over 1 plus E sine theta. So this means that our directrix is on the positive y-axis. So positive y, like that. So E, the coefficient of sine is 1. So E is 1 multiplied by D, which is equal to 22. So the directrix D is equal to 22. So found a directrix there. Then find the directrix 22 with E being equal to 1. So when E is 1, then we know this guy is a parabola. That's how we are discussing it. After saying it's a parabola, and we have E1, we have D 22. This 22 is equal to Y. So you pick another property there, very important. So let me write it which one. So we're saying since D is equal to 22, then Y is equal to 22. So directrix. Then now we seek to sketch this. So how do we sketch? For such, you just go to an angle. So pick the angle theta. The important ones 0, 90, 180, and 270. And then this is theta. So if theta is that, then what is sine? And then r. So sine 0 is 0. So r is equal to 22. And then sine 90 is 1. So r is equal to 22. So sine 90 is 1. So r is equal to 22 over 2, because we have 22 over 1 plus 1 as r, which is 22 over 2, which is 11. So we get 11 here. And then sine 180, another 0. So we have 22. And then sine 270, and that's -1. So it's undefined. So -1. So this guy is undefined. Okay. So because undefined, we can now sketch. So we're saying at 90, we've gotten 11. So since our directrix is 22, and then the other guy has given us 11. So 11 at 90, at 0, I've been given 22, and then at 180 we've been given 22, so it will be -22. So we can have us a sketch for this parabola like this. And that's how we sketch. So this simply means that the focal point is at the origin. And remember, we talked about this. We said that for the polar, the focus will be at the origin. If it's a parabola, which only has one focus, it will be at 0, 0. If it's a hyperbola, the one that you sketch, because for the hyperbola, normally you don't sketch two of them. The one that you get to sketch is the one whose focus is at the center. If it's an ellipse, the focus is at the center. One of the four sides will be at the center. This is how you discuss this. Now, this was just an eye opener that, okay, though it may not be this hard, your quizzes, because the one setting is Dr. Band, of course. So you need to get these past papers. He was the one taking this course last year. So you must have past papers for the guys for last year, because that's how he sets. So he's going to bring some of the things. If you just change some numbers, but same concepts. So this is from Mr. Chisha for 2100. Of course, they can't set the same, but we've just done it because of picking from the same topic. Like this question, he can ask you to sketch something like this, and then you just get the logic that say, oh, okay, so if I have sine, it's plus to face down, if it's minus, it's to face up, and this is how it goes. So please, if you pick up the past papers for last year, you can appreciate if you share in the group. Said, when is the quiz? I think they talked about the quiz at some point.
It's not yet clear if it's Tuesday this week or the other one.
Okay.
Sure. But which one is this 2100? It's for mathematicians or what?
Yeah, this one is for
It's
mathematicians.
for school.
Yes.
Hey. In your cover.
No, but but 2110 is harder than 2100.
Pesika muntu aruma chepeni balazi.
I think
Sure.
mostly what I've noticed is that 2110 is a bit thicker than 2100, because in this course you also do series and the like. The other one they just do calculus. It's all calculus. So except topic one, it depends on who is setting. So you can pick any questions.
So, as we're doing 2100, you won't be focusing much on us.
2100. No,
Yes.
because now we have, this is exactly everything from 2100. So when there will be a distinction, then I'll mention that there's now a distinction. So the concentration will be not for one course, but then we'll have to have splits, like when the other ones do series, because there are no series in the other course, so you can learn the series to help learn your own content.
Sure.
Okay, so we end here for this night. Tomorrow we'll have our class. Tomorrow we'll get back the
Thank you so much.
and finish up the questions that we did not do. Most of them are applications like question 1, the one that we are doing tomorrow from the theory sheet.